Okay, so we have a few more types of contraction that we need to introduce. Number one is a twitch contraction, and you can see it's a pretty simplistic definition. It's a quick jerk of a muscle that occurs when an entire muscle is excited at the same time. So key word here is, or words, is jerk, quick jerk, meaning it's singular. So a true definition of a twitch contraction is just one jerk of a muscle. Now, this doesn't really happen unless we're in a laboratory setting. For example, when you're walking, when you're talking, when you're moving, when you're moving your arm, your nervous system has to send multiple messages to those muscles in order for that to work. A true twitch is just one stimulation to where we have one excitement of those ions, those sodium ions rushing into the muscle, and then that's it. So the only way you actually show this or illustrate this is you're in a lab and we have a probe that sends electricity to the muscle, and the probe is controlled by a computer, and you only shock the muscle one time. So we can introduce multiple twitches at a time, but that's more where we call they have different names for those things. So a true twitch is just one contraction due to one stimulation of the entire muscle. Okay, and then another type of contraction is called trep contraction, also known as the staircase phenomenon. And this is, as you can see, it's a step-like increase of strength. So what happens is this is what we call the warm-up type of contraction. So if you take a look at the picture on the right, the amount of tension is on this y-axis right here. So it's how well you can tense or contract that muscle. And then on the x-axis is time. So what we're doing is we're contracting the muscle, about 8 times in this picture. So picture waking up first thing in the morning and trying to make a fist, right? It's kind of hard to do, right? Right when you wake up, all your muscles are kind of weak, right? So the first time you make a fist, your muscles can only contract so much, and then when you relax them, they just go back down the rest. And then you try to make a fist again, and it's still kind of hard, but it's probably a little better than the first time. And then you do it again, and it gets a little better, and a little better, and you get where I'm going. With every contraction that you get, the muscles get a little stronger, and then here you can make a full fist that's strong just like normal throughout the day, right? So what happens is we are resting the muscle, but we're repeatedly stimulating it to kind of wake it up and get it at its full strength. So the whole principle behind it is the more you contract it after a few times, the more forceful this muscle can contract. So basically you're warming it up. And this is the whole application behind why athletes do a pregame. Why do they start jogging and moving and shooting hoops or whatever sport they're playing? Why do they warm up before the event? Well, one, it's to get the blood flow going so they don't pull anything, right? It's to get their bodies somewhat warm and ready for action. But from a muscular standpoint, it's this. So say that we are playing basketball. If I need to jump 30 inches in the air to dunk a basketball, it's kind of hard to do that unless you're a freak athlete. It's kind of hard to do that right when you just stand up and get off the bench. But if you start real light and just do a layup or just do some jumping exercises and you do that 15, 20 times, then yeah, you have no problem dunking in the game. So you got to warm up the muscle, and as you warm up the muscle contracts more efficiently. It contracts better. Now this will continue to happen. This trep, this staircase will continue to get better and better, and the muscle will continue to contract more optimally and more optimally until you get tired. There's a limit to everybody, right? So you will exhibit fatigue eventually. You can only warm up for so long. You can only play basketball or tennis or whatever we're playing for so long. And eventually this will decrease, right? We're not robots. But certain people can go and go and go and go for a very long time. Eventually everybody will tire out though. So that's trep. And one more type of contraction is called tetanic contraction, also just known as tetanus or tetany. And this is a contraction where you're not giving the muscle enough time to relax. So it's a prolonged contraction, and you're continually shocking it with that electricity. You're constantly sending those nerve impulses to the muscle very, very rapidly to the point where we do not have time to rest. So if you remember with the trip example on the previous slide, the way the graph kind of looked was like this. The muscle went up and then it came back down the rest. And then it went up a little higher and it came back down the rest, and then a little higher and rest. If you notice the pictures on the right, we're not going back down the rest here. We're actually building on it. So we're sending multiple waves of electricity to the muscle, and that's why this form of contraction is also known as multiple wave summation. Summation meaning summing, like we're adding these waves on top of one another. So if you look at the first picture, this is actually what we called unfused tetanus or incomplete tetanus, but you contract the muscle, and before it has a complete chance to relax, we are contracting it again and again and again. And you're kind of seeing the same effect as TREP. You're seeing this staircase phenomenon, but this is not really dealing with warming up. This is dealing with you're not giving the body enough time to relax. So this is an example, kind of like running, if you will. You just keep going and going and going and going. Your muscles are constantly working. So it doesn't exactly create a series of, it does. It creates a series of twitches together, but remember the true definition of a twitch is just a single contraction. And this can be so extreme. If you look at the picture on the far right, this is called fused tetanus or just full tetany. And where there is no building, it's just straight max effort. So the muscle has zero time to rest. And this is like, for example, if we're moving a couch and you're holding the couch up and we're going down the stairs, you don't have a choice. You have to hold on to that couch. If your muscles let go, we're both falling down. We're going to hurt our back and then we're going to fall down the stairs, right? So your muscles are tensed and they are not getting a break at all, pretty much. So big keywords here. It's also known as multiple wave summation, and we are not giving the muscle enough time to relax before the next contraction. So we're really taxing the muscle. Okay, we talked about a lot of different types of contraction over the last few slides. So this slide is a really good way to just kind of slow things down, take a breath, and review, and make sure that we're understanding the different types of contraction that we talked about. So let's just start with number one, and you can kind of just work with me. Well, actually, I would encourage you to pause the video and do this on your own. Let's do that. Pause the video, do this on your own, and then come back and compare your answers with me and work together with me. All right, so now that you've hit the play button again, let's start with number one and look at the possible answers. So a tonic or tonic contraction is number one. And remember, with tonic contraction, what we're looking at is your tone. This is basically when you're just hanging out and you feel grab your whatever muscle, your triceps muscle, even though you're not extending your elbow, there's still tautness, there's still some tension in that triceps muscle, even if you're not using it. So look at all these different answer choices, and what you'll arrive at is A doesn't look really that great, B looks a little funny, C's not quite right, D, that looks pretty good. Maintain posture, right, with tone. So we talked about sitting upright or standing upright or walking. These muscles are undergoing something called a tonic contraction. So what we'll do is put D for number one. That should make sense. Number two, isotonic contraction. Remember, isotonic is you're moving the joint. You're actually changing the length of the muscle. So A and B look pretty promising. A is something that's too heavy. B is the length is changing. The length of the muscle is changing. So B looks good. Isometric is where you're contracting but the muscles are not changing. And the examples I gave you was a plank, was a wall sit or lifting something too heavy, right? My bench press where I get stuck, that kind of thing. You're not going to be able to move the joints and the muscles the way you want to. So that would be an isometric contraction. So then we're just down to the last three. We have twitch, and remember, twitch is just a singular movement. So the only one that's singular, you see C is prolonged, E is gradual. So a quick jerk of a muscle would be a twitch. So we'll put E. And then we just have it narrowed down between trep and tetanic. And remember, trep is the warm-up one. That's kind of the building up one. I mentioned the squeezing your fist in the morning. The more you do it, the stronger it'll eventually get. And then that leaves us with C for tetanic, which is the prolonged muscle contraction. With repeated stimulation, we don't allow the muscle enough time to rest. So hopefully your answers line up with mine. And if they don't, no big deal. Just rewind the video and review these studies a little bit more, and then compare your answers down the road. And just make sure you understand this before your next exam. All right, moving on, let's talk about the different types of muscle fibers that help us do certain activities.